Recharging groundwater is crucial to replenish underground water resources, often tapped for drinking water and irrigation. A suitable water supply method has become crucial in times of water scarcity. Under normal circumstances, water coming from the catchment area keeps flowing without lifting the water level. A solution to depleting groundwater is the construction of check dams. Check dams are watertight structural barriers built across the direction of water flow. They collect and store runoff water during monsoon rains or are built on shallow seasonal drains or streams to store flowing water to a certain level and allow excess water to flow down the stream. Water retained by the structure percolates into the ground to recharge the aquifer. The purpose of a check dam is to check the stream flow and create a reservoir of water which can percolate into the ground, augmenting the groundwater resources. A check dam is constructed in the lower elevation of a watershed, usually on third order or higher order stream, where the slope becomes very gentle, example, less than 5%. The selection of proper site for the construction of a check dam is done on the basis of specific criteria. What to take care of when choosing the construction site? The do's and don'ts. The do's. The valley or stream should be narrow. The banks of the stream should be strong enough to hold the stored water. The site should be selected at a linear stretch of the stream providing maximum storage. Sites located at good porous and permeable strata will have high recharge rates. Sites should usually be selected near the agricultural lands to provide immediate benefit to the farmers. The don'ts. The identified site's bed should not be very deep. The slope of the bed of the stream should not be more than 5%. Sites with fragile or weak foundations such as deposited sediments, loose soil, shear zones and fractured rocks should be avoided for the safety of structures. Hard rock strata occurring at a minimum depth below the soil provide a strong foundation. Sites near dense tree cover should be avoided as the roots may damage the structure. Site on sharp turning or meandering should be avoided. Sites near a massive rock should be avoided as recharge may not take place from such formations. Construction of a check dam. These water augmentation structures are of various sizes and shapes at varied locations as suitable to the specific needs such as for reduction of the velocity of flow, reduction of silt load, reduction of soil erosion, etc. Complementary structures constructed on second order stream with less than 20% slope like nala bunds, loose toll gabion structures, etc. depending on the purpose and construction technology. Check dams help conserve rainwater, especially during the monsoon seasons with abundant rainfall. This stored water can then be utilized for agriculture purposes, livestock and domestic needs during dry seasons, reducing dependence on erratic rainfall and preventing water scarcity. The components. Number 1. Core wall. It checks the flow of water through the dam section. It may be of compacted puddled clay, masonry or concrete built inside the dam. Number 2. Spillover. The top of the spillover part should be covered in the vertical plane to dissipate the kinetic energy. Number 3. Sidewall. The objective of providing sidewalls is to contain the flow within specified limits and to train the flow in a streamlined manner to minimize the turbulence and impact on the side abutments. Number 4. Cutoff wall. Cutoff walls are used to prevent unwanted movement. They act as seepage barriers to isolate an area both upstream by retaining water in the dam's reservoir and downstream, protecting the water. Number 5. Cushion chamber. Cushion chamber is a water trough receiving overflow water. This saves the structure from caving in by dissipating the kinetic and static energy of falling water and hydraulic jump formed. Design of a check dam. A check dam is generally designed based on the following 3 parameters. A. Hydrologic design. The parameters like rainfall, runoff coefficient, soil type, texture and structure of the soil, land use, land cover and other climatic factors. Average annual rainfall data for a minimum of 20 to 25 years in the watershed areas are considered for better design. B. Hydraulic design. The hydraulic design discusses the calculations of the structure's dimensions, through which the runoff is disposed. The crest or the head wall of any wire or check dam is designed hydraulically so that the peak runoff can be discharged safely through it without spilling away the water and causing damage to the nearby areas or the structure itself. The correct engineering calculations thus become vital to ensure the safety of the check dam. C. Structural design. The structural design contains the dimensions of every part of a check dam, including the extensional wall, wing wall, apron, baffle wall, water cushion, etc. The calculations are required to ensure the stability of the structure through its required weight. The weight of the check dam can only be ensured by providing calculated dimensions to all its parts. The structural design provides stability to the structure and prevents it from sliding or overturning. Since the size of check dams is comparatively small in the watershed, hydrologic and hydraulic designs are sufficient to estimate the actual design. The other dimensions of the check dam can be designed based on site conditions. To ensure a check dam's safety and security, horizontal and vertical pressure acting on it must be calculated in advance and considered during the designing state to avoid structural failure. The ultimate aim is to increase the groundwater recharge. After this, the community members take charge of the operation and maintenance to ensure long-term sustainability.